In the area of energy, if we can nanostructure a surface, then with that nanostructure we can control its interface with the environment. And because of that nanostructure, we can build surfaces that can capture and convert energy in a more efficient manner. For example, in solar cells, or you want to capture sunlight and create electricity from that. Or to take that a step further, if we wanted to capture that sunlight and transform other chemicals into a useful fuel, and if that other chemical just happens to be water, there's plenty of it, then we can build new water splitting devices. Again, the nanostructure is critical. Still in the area of energy, but more related to the application of energy in medical bionics, we build new nanostructures to create flexible batteries and capacitors that can be integrated into wearable garments, or implantable batteries and capacitors so that they can power implantable devices for medical bionic applications. So the chemistry won't get too complicated, but there's a pretty scary slide coming up in a couple that I'll warn you about it before it comes on. But as I said before, the chemistry doesn't need to be complicated. This is carbon. You can't get any simpler chemistry than this. Right? Everybody in this room must remember carbon from some chemistry lesson somewhere. It's ubiquitous, it's everywhere, it's boring. Well, it's boring until you take it to the nano domain. Even if we take carbon, boring carbon, down to the nano domain, and we can create structures, as we can now, where we can control the size, for example, the diameter of a carbon nanotube. That structure is just single layer of carbon atoms wrapped up into a tube, and you can control the diameter of it, control the length of it, using nanofabrication tools that have been developed just in recent years. And the ability to control those dimensions means that we can control the physical properties of that carbon structure. We can create materials that are stronger than steel. We can create materials that are super ballistic in terms of their ability to carry electrons. They're fairly complicated structures to make. At least on the face of it, we've had to spend many years in developing the protocols to do that. And then there's this other really simple, amazing discovery that happened just a few years ago and won the Nobel Prize this year, and that is the discovery of graphene. Graphene is not sophisticated. If you take a pencil, it's made of graphite oxide. We take that graphite oxide, we boil it up in some sulfuric acid or some concentrated oxidizing agent, we'll form graphitic oxide in solution. You can reduce that with very simple chemistries to graphene. That's it, simple chemistry. You can't get any simpler than that to produce at very large scale nanoparticles of carbon that have extraordinary properties.